I am Kit Woodrull, the Regional Distribution Manager here in Michigan and Northern Ohio. And Nick Clute will be presenting today. We want to thank Electro-Matic for hosting this, and we're going to discuss Turck's safety products, safety IO products, etc. Nick, I will let you go ahead and take it away. I don't know if there's anything specific you want to mention about chatting or any of that ahead of time, but go ahead.
Yeah, I mean, it's kind of like we've done in the past a little bit. So as far as we're going to have some opportunities for questions. So if you have any questions, please feel free to put those into the chat. And Kit will make sure that I get to them towards the middle and at the end. So yeah, my name is Nick Clute. I'm the Business Development Manager for Turck, also in Michigan and Northern Ohio. And my responsibilities are for anything that's technical inside of the Turck's portfolio. So whenever it comes to connecting things to PLCs and controls, that's kind of where I fall in. So today we are going to be talking about the various different safety IO modules that we provide, as well as show exactly how you get these things set up and connected to safety PLCs. So first we're going to be talking, these two products here are considered our full safety modules. They have 8 points of safety IO, and they come in 2 different flavors, both SIP-Safe and Profi-Safe, as you can clearly tell by the colors. When we look at the types of signals that we can get inside of this module, on the left side of the module, we have 4 digital safety inputs. Now, when we talk about safety inputs, these devices are performance level E, and so each one of these 4 are already dual channel. So technically there's 8 signals that are being evaluated, but those signals are being combined into 4 safety inputs. So these safety inputs can actually be configurable to be whatever you need it to be. So the first type of signal that you might have is a standard dry contact or an e-stop signal, where test pulses are being generated by our block, being passed through the normally closed contacts, and then being reevaluated back at the block. So that if there's any disruption in the signal or in the ability and control, we have that diagnostic coverage. We take a look at the types of devices that we would use here. These are your standard e-stops, pull cords, anything that's going to have dual normally closed dry contacts. The next thing you might have is, instead of dual normally closed, you may have anivalent. This means that you have 1 normally closed and 1 normally open. These are typically used for gate switches or safety sensors as well. The other main type of safety device that you're going to have is electronic inputs. These inputs are going to be taking care of their own level of safety. They're going to have their own diagnostic checking inside and everything else. So all we're going to do is provide power and wait for the signals to come back. Now what you'll notice is on this diagram here, you'll see the pulse test. Those pulses are not generated by our block, nor are they required. We're not evaluating them. What we're doing is we're just making sure that we can tolerate them and don't shut off the safety system just because there's a pulse. Those pulses are being used by the electronic device itself in order to make sure that it knows whether or not it's in control of its own signals. Take a look over here. We can add in laser scanners, some types of gate connections, and obviously the light curtains, as well as some anivalent OSSDs for some anti-tie downs or tie downs. All right, so we've got our left side of the block taken care of. Let's jump over to the right side of the block. On the right side of the block, we have 4 configurable safety channels. So this means that they can be safety inputs or safety outputs. So the same safety input devices that we had on the left side can also be on the right side. So this block can be a full 8-channel safety input out into the field, but it also has the ability to drive safety outputs at 2 amps apiece. You can either have what's called dual high side transistor, where the power will pass through two safely controlled transistors before exiting. And then you also have what's called bipolar, where we're going to be running through a high side and a low side transistor. And so what that does is it just gives you more diagnostic coverage inside of your safety setup. We also have, along with the hybrid, we also have what's called along with the full safe, we also have what's called a hybrid. These hybrid safety modules are part safety signals and part standard signals. You might wonder, like, okay, what's the reasoning for that? Well, what we've seen in the field is oftentimes there's a standard block and a safety block. They're right next to each other and they're only partially used. So by using a hybrid, we're able to combine those signals into a single device. So let's take a look at what types of signals we can get in this hybrid. So you have your two digital safety inputs, and then these are the exact same circuits that we use in the full safe, which is the dry contact style as well as the electronical OSSD. We also have two safety configurable, which again is going to have the same inputs that we had before, as well as the dual high side transistor and the bipolar output, both 2 amps. Here's where we get into the hybrid side. If we jump over to the right side of the block itself, we have actually 4 digital safety channels, 2 ports. So it's a 4DXP if you're familiar with the Turck nomenclature. These points can be either inputs or outputs, and you don't have to configure the outputs, configure them to be either. They show up in both the input and the output tables. And so it becomes an output when you turn on the coil in the PLC. We also have 2 IO-Link masters. So if you've got any sensors that are IO-Link compatible, or if you want to get more IO, you can get up to 16 points of digital IO, which means that just on this block alone, you can have 36 points of IO. Actually, 38 counting because pin 2 on those IO-Link master ports will also have a DXP channel. So one of the things that we were looking at is oftentimes when you're, doing a gate entry or you're doing an operator station, you're going to have a request to enter push button. You're going to have various, resets and whatnot. But the other thing that you may want is you may also just have like one solenoid valve. And so how can you safely shut down that particular output in order to, and what we didn't want to do is we didn't want to have to bring in like safety power into the safety device like you normally would bring safety power into the top connectors. That would be kind of silly for a safety device. We also have these safety outputs. Well, maybe you don't want to blow an entire safety output just to run, one valve or something like that. And we also didn't want to use it to like drive the output power of the block. And so what we've done is we've actually added 2 internal safety relays, effectively, safety transistors. One that controls the power for the digital points on the top right-hand 2 connectors, as well as another one that controls the bottom IO link device. So this means that you can run like a valve manifold and you can shut that power down without having to shut everything down on the block. And you have complete control from your safety PLC. If we look at kind of the diagram here, you can see a little bit more. So those FSOs, or the functional safety outputs, 0 and 1, that are internal, stand between the V1 power and the power that's going out that's being driven on the DXPs, as well as the second IO link port. So when you're setting up our safety modules, because you have the ability to switch between so many different things, between the safety inputs, the electronic inputs, or the safety outputs, we need to have some way of setting that. And we have to have control. Like, in order to be safe, we have to have complete control and make sure that we have ways of documenting how this is set up so that inside of your safety systems, you have that capability. So we do have a safety configuration software, which I'm going to be going through in just a moment. And what you'll find is really all you need to do is just select what types of I/O you're going to have on each port, and that's about it. So you'll be able to take the information directly from the safety configuration software and get the information that you need in order to commission these directly in your safety PLC. You can also use the safety configuration software as a method to use these blocks in a standalone method. So if you do have a small machine or a work cell or something that just needs, an e-stop and a light curtain to shut off, one output, we can do that right on the block itself and not need to go back to a safety PLC, yet report all of those safety signals. So you'll know when the light curtain is broken, you'll know when the e-stop is pressed. But the PLC itself doesn't have to be in control. Now, once you get that set up, it is going to generate those safety configuration codes, the timestamps, everything you're going to need inside of the safety PLC. So once you get that set up in the field, let's say, heaven forbid, a fork truck runs into it and takes it out. Well, what do? What's the device replacement? Are you going to have somebody who knows how to use that safety configuration software? Are you going to have to be able to get into the PLC and change the safety? No, with our device, we actually have a memory chip built directly into the device, right under the window, so it's perfectly safe from the elements. And you can move that directly into another device. And what it does is it retains all the settings, even the IP addresses, and you'll have no change to your configuration signatures. So you just plug that into the new device, power everything up, make sure your rotary switches are set the same way, and you're off to the races. So the other thing that's kind of interesting about when you have an IP67 I/O block, the question then becomes, well, how do I use that I/O block? If I've got other I/O blocks out there that I need aux power for, like I said, the safety outputs on our devices are 2 amps. I mean, that's good. That's definitely going to drive a lot of outputs, but it's not going to drive an entire I/O block worth sometimes, or a series of I/O blocks. And you might put a safety output inside of the panel and drive that from the safety PLC, but what if you wanted to do it in the standalone mode? Or what if you were trying to accomplish almost a panelist system? How do we make it so that the connectivity isn't a nightmare and you're going to get the power that you need? So what we did is we set up this safety shutoff box, which is an IP67 box that brings in a 24 volts power, the same power that you're driving your safety block with. It brings in the safe input. It has the dual contacts inside of it, and it will combine those unswitched and switched power into 124 volt signal that you can then bring out into the field for your I/O blocks. If you need, it also has the contact control, or the EDM, the monitoring, which will tell the system and will increase your safety diagnostic coverage. So this box looks like this. Like I say, on the left-hand side, you've got power in. On the right-hand side, you've got power out. It's got voltage sensing to make sure that you're not cross-circuited. You've got the LEDs directly on it. You've got your EDM signals, and you've also got your safe input. So it's a really good solution for not making a huge mess out of connectivity if you want to maintain a completely IP67 system. All right. So before I jump into the technical demonstration, do we have any questions at this moment?
None in the chat.
Okay. And again, we'll definitely have some opportunities to do more of that afterwards. So we'll go ahead and pop over here. So the very first thing that you're going to want, if you're going to be working with Turck devices, is Turck Service Tool is one of the nicest tools that I've had the pleasure to work with. I've got to watch this kind of evolve over the years. And the idea here is any Turck device that's on your network is going to respond to this tool, regardless of whether or not it's even in the same IP. So if your system is 10.202 and you grab a new Turck device, you're going to see the 192.168, even though your computer is set for the 10.202. And you can change it right there. So what I do here is I've got mine set up as a PGM DHCP mode, which means that it's going to respond to, let's see, 232, 233, sure. And what that means is that it's going to respond to Turck service tool requests, DHCP requests, boot P requests, and Profi naming requests through DCP. You can also change the rotary switches on this device, and you can set the last octet of the IP address using the rotary switches. In the Profi safe version, those rotary switches are reserved for your F address, so slightly different. So now that we've got our IP address set, we can then go into the Turck service or Turck safety configurator here. And what we're going to do is we're going to create a new configuration, a new safety configuration. And we're going to select what device we have on the desk. So on mine, as we saw over here, we have an L4 2IOL, right? So it's the hybrid version is what I've got here. So we want to match that. Then what it's going to do is it's going to, okay, what do we want to name it? I'm going to leave it at default. And then the base configuration. So right out of the box, I want this thing to be used on SIP-safe, right? So I'm going to go in and my local IOs, I've got an e-stop on my first top left-hand connector, and then I have a light curtain on the second. So I'm going to grab an active optoelectronic protective device. I maybe have practiced that once or twice, but I got a light curtain, and that's it. I'm done, basically. So when I hit OK over here, what's going to happen is it's going to automatically generate the configuration that I need in order for all of my safety inputs to be sent to SIP-safe. So over here, we can look at my 166 SIP-safe output. So the bit that's going to SIP-safe is being driven by my light curtain. And I've got another SIP-safe bit that is being driven by my e-stop. I've also got the safety outputs that are being, the safety output is being driven by the SIP safety. And same thing with my internal safe outputs. So let's go over here. So then what I want to do is I want to send this to the device, PC to safety monitor. I want to use Ethernet. Now I've got 233. So what we'll do is we can actually search for it right inside of the configurator here. So it's going to do the same thing that Turck Service Tool did. It's going to find it for us. I can hit flash LED here, and that'll turn on a strobe light. So we can hit OK, make sure we know exactly what device we're talking to, and then it'll say, okay, do I want the interface? Yep, I do. Yep, and a password. So the standard password for all of the Turck devices is Simon. And it's going to say, okay, we need to assign a password. That's part of the safety process. So we'll go ahead and reassign a new password to it. And then what it's going to do is it's going to take the safety configuration. It's going to create a plain text log and a visual diagram that you can use, like I said, inside of your safety documentation. So what it's going to do as well is I have to then sign in. Now, it's not like it's got a database, but what it does is it's just going to keep a log that Nick was the one who says, I ensure that I will check the configuration log of the monitor. Again, everything about this process has to be very, very safe, right? So then it goes through and it validates, it creates this timestamp and the code. Activate protective mode, yes. So what it's going to do is it's going to download this configuration directly to the safety block, and then it's going to verify. It's going to go through all of its checksums, and it's going to make sure that all of the information that we intended to send was received on the block and everything was happy. So inside of this, what you're going to want to do is you're going to want to be able to grab this and you want to save that off, because what you're going to need in SIP-safe is this configuration signature as well as the timestamp if you want to use the safety configuration signatures on the safety PLC, which we recommend. And then over here is your code, is the ABB5. That would be something you're going to grab if you're going to use ProfiSafe. And we'll show that here in just a second. So We'll go ahead and close this. We're in online mode right now, so this is showing the current values of the system. I don't have a SIP-safe master with me, and so I'm not sending any SIP-safe bits. We're not getting any greens there. We've got my e-stop here, so if I go ahead and click that, that is going to be transmitted, and if I break the light curtain, you're going to see that as well. You may have a few other colors inside of this as well if it needs to test the input, or if it needs to reset for any reason, or if you get cross circuit. Like if you get a flashing red is really bad, right? So you may have those test pulses that are showing up into a different spot, and so you're going to see that as all red. All right, so the next thing is I want to show you how this gets set up in the Profi Safe system. And I don't have, Siemens and Allen Bradley aren't very happy. So I'm going to do Allen Bradley live, and I'm going to do the Profi Safe as just screenshots. And so when you're inside of TIA Portal, what you're going to do is you'll have a system that has a safety PLC set up. You're going to install the GSDML file for the TVPN, just like you would. You're going to bring that into your Profinet system. Then what you'll do is you'll go to the device itself. On the right-hand side, you'll notice that the ProfiSafe module is a slot inside of this device. If you go to the parameters of that device, then what you're going to do is you're going to, in the properties of the ProfiSafe, you're going to put the number that you set the rotary switches to, which is your F address, into the destination address. And then your IPAR CRC is going to be the value that you get from the safety configuration. And that's it. You're done. All of the other information that you're going to need is going to be done through ProfiSafe. And if you've got a hybrid block, all of your standard I/O is going to show up just like any other I/O inside of the GSD file. So you set up your hardware configuration just like you normally would. So there's really not a whole lot of steps in order to get this going. Then we'll go ahead and pop over to the Allen Bradley side. All right, so in Allen Bradley, they do not allow for third-party devices to have configuration files for safety like Profinet does. So what we do is we do what's called a catalog file. So when you go to the website, right, if you go to the Turck website, and you type in your safety device and you go to configuration, you go to download configuration. We have EDS files and catalog files. The EDS files, we have some for safety for other masters, and we also have some for just the standard I/O side. But it also comes with the catalog file. So when you download that, you've got, let's see, you're going to have what's called an L5K file. So an L5K file is really interesting. So our biggest goal in the Allen Bradley world is we really want to avoid version control issues, right? So what version of Logix do I have? What version do you have? What version did your project have initially? We want to avoid as much of that as possible. So an L5K file is nothing more than an existing project. And then what happens is when you go to open it, it's going to then ask you, where do you want to generate the ACD? And then this ACD file is more specific to your RS Logix installation. So then when you open that, that is going to be what we call a catalog. If you're looking at this and you're kind of like, wait a second, that looks kind of familiar, you're absolutely right. We patterned this off of a Profinet catalog system. The idea is that you set up your standard Allen Bradley system here, you go over into the Turck catalog, you grab the device that you want, you click and you drag it into your system. Just like selecting a GSDML out of the device catalog is the same thing that we're patterning this off of. Allen Bradley allows you to drag things from one project to another. And the great thing about that is all of the things that you would have a problem with when setting these up as generic devices, And this is true for either a safety device or a standard device. Even if it's just an all standard 16.io, we have a catalog file for it. And so what that means is that you have the ability, when we drag it in, we've already set everything up for you. So in a safety system, you have to have all these module parameters set right. You have to have the assembly instances for both the safe and the standard side. So everything is already set up for you. All you do is you set the IP address. Then what we would do is in the safety, we would go over here. We would fill in that configuration signature, the same as before. We would fill in our timestamp. Now here is the number one gotcha inside of any of these systems, is that if I go back and I look, let's see. If I were to look in the configuration log that we grabbed earlier, what you would find is that it brings you the time as UTC, Universal Time. And so what you have to do is your Allen Bradley installation is in a different time zone. So you have to adjust for that. So if I'm in Eastern Time, Daylight Standard, I'm going to have to subtract the 5 hours from UTC, which is a little bit confusing because the safety configurator doesn't give you it doesn't actually convert it back to UTC. It takes your existing time and makes it UTC. So that is the number one gotcha there. And then what you're going to do, once you get those set, you'll go online and then you have to set your safety network number. What you do is you go to your safety controller here. You're going to grab the safety network number from the controller itself. You're going to copy that. And then you're going to come over here, safety network number, and you're going to paste that in. And then when you're online, you can hit set, and then that will set it on the device itself, and you'll be good to go. You'll have all green lights. So what we do is we go into the controller tags. This is the second piece of magic that we have by using the catalog file, is that when you go into the controller tags themselves, everything's labeled. So there's no question. You can just go in here, you're going to grab your FDI01. This is where the bit is going to be for that e-stop. One of the things you'll notice is that we're already pre-evaluating that, the timing of the closing of the contacts. If you want to change that timing, you can either set it in the safety configuration, or you can use the safety configuration and send individual channels into Allen Bradley and use the standard functions that you're already used to. Either way, but if we evaluate it on the block, you are going to have a faster response time of the safety system, thereby changing some of the parameters. So we'll also notice is that because this is the hybrid, because you have both safe and standard, if you go into the iData, you're going to have all of your standard data pre-labeled, ready to go. You're going to have all of your DXP values here. You're going to have your safety diagnostics available, and you're going to have all of your IO link data available. The other thing that's really interesting about using catalog files is that you also get this C data. The C data is what controls the standard configuration data, and this is true for both safety and standard devices. So as you know, you may or may not know, you'll have to find out in a different IO Link seminar, but IO Link can just default to becoming digital IO, so you might want to disable that. We can do that directly from Logix by just changing this value here. It says 1000 is DI. We set that to 1000. And when it downloads, it's going to send that information down. You don't have to go to a web server. You don't have to go to a separate separate software. So we're always trying to look out for as many different ways for device replacement as we can, try to make this as easy as possible. And kind of like the Profinet world, we want to make sure that you only have to use one tool in order to do all the setting. Awesome. Any questions?
A question came up in the chat about IO Link and how to set up the extended IO modules.
I'm sorry, what about the extended IO modules?
How to set them up in the safety block.
As far as for safety signals, or just how to get them into the PLC?
I'm guessing in regards to the IO Link, like a
So I'll just answer it both ways. So okay. The IO Link is going to be part of our standard IO process, so it's not going to be part of the safety task. All of that data is just going to get passed into either Ethernet IP or Profinet. And then what we do with our IO Link devices is we have no setup required. So it's just like the DXPs, is that both you're going to get all 16 bits mapped. If you're going to get them all mapped to both the input and the output table. And if you write to the output, it becomes an output. You don't have to set anything up on those devices. Please feel free to reach out to Electro-Matic or Kit or myself. I really appreciate everybody being able to attend today. Thank you very much.